Hello, pre-cal boys and girls, and here is Chapter 2 test review video problems that I have selected for you. We're going to start by finding all the asymptotes and if we have a hole and what is that hole's location. So first thing we want to do is check the degree of the numerator and the denominator. So in number 1, the degrees are the same, which tells me that we will have a horizontal asymptote. So if they are in descending order and lined up, then just check those first two terms. 2x squared over x squared reduces to simply y equals 2. That is your horizontal asymptote. Next, let's take a look. Is it factorable? And we really should factor it first. Probably should have done that, but that's all right. So if we factor it first, we get y equals, and I'm looking at this numerator with a leading coefficient of 2 and a backside of 8. This numerator is not going to factor, so we're just going to leave it like it is, but the bottom will. There are factors of -6 that add up to -1. That's x minus 3 and x plus 2. So since nothing canceled, that's why we have our horizontal asymptote. Use those two factors in the bottom to find the vertical asymptote. This time there's going to be 2 of them. One at x equals 3 and one at x equals -2. Please remember to write x equals 3 and x equals -2, because if all you do is list the numbers, I'm not giving credit because those are numbers, not equations of lines. The domain for this function would be all real numbers excluding 3 and -2. Remember that the vertical asymptotes are directly tied to the domain. So -infinity to -2, union, -2 to 3, union, and 3 to positive infinity. So that's what I'll be wanting to know about number 1. Number 2, is the top factorable? No. Is the bottom factorable? No. So next, look at that denominator, x squared plus 1. Is there any value that is going to be restricted if x is being squared and we're adding 1? No. So the domain here will be all real numbers. So if the domain is all real numbers and if the denominator is not factorable, then there are no vertical asymptotes. Next, the degree of the numerator is exactly 1 bigger than that of the denominator, which means we will have no horizontal asymptotes, but we will have a slant asymptote. And remember, this fraction bar means division. So let's use long division and let's determine what the slant asymptote is. So -2x cubed plus 0x squared plus 0x plus 0. Remember, every descending power of x has to have a representative in both the numerator and the denominator. So to the denominator, x squared plus 0x plus 1. So let's complete this long division and find the quotient. X squared goes into -2x cubed, -2x times. So we multiply, we're going to multiply next. -2x times x squared is -2x cubed, -2x times 0, plus 0x squared, plus or minus 0, it doesn't matter. -2x times 1, -2x. And like I said in class, I use a different color to draw the line and change the signs just so I can remember that I actually did it. So first column cancels, second column cancels, we're left with 2x plus 0. Now, if you take a look, x squared will not be divided into 2x. Therefore, this is the remainder. There's nothing else left to do. So what is our quotient? Our quotient is simply -2x, which means our slant asymptote is y equals -2x. Once again, this should be in slope-intercept form. So if you just say -2x, it's wrong. You need y equals -2x for the slant asymptote. Once again, when do we get a slant asymptote? When the degree of the numerator is exactly 1 greater than the degree of the denominator. Next problem. Y equals x squared minus 4 over 2x squared plus 7x plus 6. This looks factorable on the top and the bottom. The top is the difference of squares, and the bottom is a trinomial with a 2 up front. And if we want a 7 in the middle, if we put a 2 here and a 3 here, 2 times 2 is 4. 3 times 1 is 3. 4 plus 3 is going to give us the 7x in the middle, plus, which means we have a factor that is going to cancel. And when a factor cancels, it creates a point of discontinuity on the graph, which is a hole. So that means we are going to have a hole at x equals 2, which also means that x cannot equal 2 in terms of the domain. So what remains? Our simplified function is x minus 2 over 2x plus 3. So we'll deal with the hole last, because first thing I see is we do have a vertical asymptote that's going to remain. So our vertical asymptote is going to be what we get when we set this denominator equal to 0. So x is going to equal negative 3/2. That's a vertical asymptote. And since the degree of our numerator is the same as the degree of our denominator, we're also going to have a horizontal asymptote. So recall that there is a 1 for that coefficient. So if you just cover up everything else except the 2 terms up front, our horizontal asymptote is y equals 1/2. So vertical asymptote, the denominator. Horizontal asymptote, the 2 leading terms. Then the hole. So in order to find the location of the hole, we need to utilize the simplified form of the function and plug in that x value in order to find the location of the hole. Obviously, if you plug it into the original function, you're going to get an undefined quantity. Plug it into the simplified version. So f of 2 will be 2 minus 2 over 2 times 2 plus 3. That's just going to be 0. So the hole's location is at 2, 0 on the graph. So let's go ahead and give that whole domain for this function. Remember, it cannot be 2 and it cannot be negative 3/2. So negative infinity to negative 3/2 union negative 3/2 to 2 union 2 to infinity. So that is everything you ever wanted to know about asymptotes and holes. Next, find an nth degree polynomial with zeros at 2 and 2 minus 3i with f of 1 equal to negative 30. So we're going to take our zeros. So if x equals 2 and 2 minus 3i, be reminded that imaginary roots always come in pairs. So you've got 2 ways to find these particular factors. You can use complex conjugates, or you can use inverse operations, which is the way I'm going to do it right now. So also what we talked about in class, these are roots. We need factors. So if your first root, or 0, is positive 2, that translates to the factor x minus 2. Now, for the second root, let's set x equal to 2 minus 3i, and let's use inverse operations in order to find our factor. So first of all, bring the 2 over, and we get x minus 2 equals negative 3i. So in order for us to eliminate an imaginary number, we need to square both sides. So that's what I'm going to do. That's the inverse operation here. So x minus 2 quantity squared is x squared minus 4x plus 4 equals, to the right-hand side, 9i squared. Of course, 9i squared equaling -1, 9i squared is going to become -9. So when we add it back to the other side, we get x squared minus 4x plus 13 equals 0. So this is our quadratic factor that is yielding these imaginary roots. So x squared minus 4x plus 13 is our second factor that we need for our polynomial. So our degree is going to be 1, 2, 3. So n is going to be equal 3 here, a third degree polynomial. 1, 2, 3, because these imaginary roots always come in pairs. So we need to multiply this together, and then we'll deal with our last piece of given information. So x times x squared is x cubed minus 4x squared plus 13x minus 2x squared plus 8x minus 26. So we get a polynomial x cubed minus 6x squared plus 21x minus 26. So this is our function so far. But we need to set this equal to f of x and find out what the leading coefficient is going to be if f of 1 equals -30. So we're going to take our x value of 1 and our function evaluation of -30, and we're going to set that equal down here, and we're going to be allowed to solve for a. So here goes. A times, remember we're letting x be 1, so 1 cubed minus 6 times 1 squared plus 21 times 1 minus 26 equals -30. So I go to my handy little calculator here and plug it in. So 1 cubed is 1 minus 6 times 1 is 6 plus 21 minus 26, we get -10. So a times -10 equals -30, which means that the leading coefficient is going to be 3. So the leading coefficient is 3. So let's go back and let's substitute in the 3 right there for the a and get our final answer. F of x equals 3x cubed. Distributing the 3 through, -18x squared. 3 times 21 is plus 63x, and then 3 times 26 is 78. So finally, here's our function. 3x cubed minus 18x squared plus 63x minus 78 is a third degree polynomial with zeros at 2 and 2 minus 3i, and passes through the point 1, -30. Yes, we do have a big fat problem just like that on the test tomorrow.